The last section we're going to look at for Chapter 2 is 2.5, which relates to applications of sets or set applications. We're going to start off by looking at an example, warm up our brains a little bit. As I read through the problem, I'm going to mark up the important information that we need to know. So they tell us that a survey is taken of 560 adults. So that is our total number of adults. The results are as follows. U is the set of all adults. T is the set of adults who watch television. And R is the set of adults who read books. 520 adults watch television. So television total contains 120 adults. 125 adults read and watch television. So read and watch television, that is 125 adults. And 10 adults did neither. So this is kind of our important information that we can use to fill out this entire Venn diagram with how many people are in each of these sets. When I read this, there's kind of two places I might want to start. The first place I might want to start is the intersection of both who reads and who watches television. And they tell us that 125 adults both read and watch television. So I know that there's going to be 125 adults listed in that intersecting section. Then they tell us that the total number of adults who watch television is, I wrote 120, but y'all should correct me, is 520. But that also includes the 125 adults who read as well. So to find out what goes here, we take the total number of adults that watch television and we subtract the 125 we already encountered. So 520 minus the 125, that gives us 395 people who watch TV but don't also read. So if I added 125 plus 395 together, I'd end up with that 520 adults that watch television. Now they told us, I'm going to use the information that they gave us here, that they say 10 adults did neither. They don't read and they don't watch television. So they're within our set of adults that were surveyed, but they aren't in any of these sets. So they just exist in that universal set of all of the adults that were surveyed. Okay? So then our last step is to figure out how many people read and only read. So we have to figure out how many people are left. So we started with 560. We take away the 520 from the television circle. We take away the 10 that do neither, and then that's going to tell us how many just read. When I subtract those, we end up with 30. So now I can answer the questions about this situation. The first question is, how many adults read? Well, looking back, we would have the 30 plus the 125, so we would say 155 adults read. Okay. How many adults read but did not watch television? So let's think about what this is saying. This is saying read but do not watch television. That goes back to our set operations. Talking today. Okay, so we go back and we say, okay, well, how many read but do not watch television? So we look back and we say, okay, well, that's A minus, or in this case, R minus T. So that's this section right here. That's 30 people. And then how many adults watch television but do not read? So that's television but do not read. So that's this section right here. That's 395. So given the information in the problem, we're able to fill out the Venn diagram and determine how many people belong in each category. That's the general gist for this section. We're going to go through 2 more examples, and hopefully you can do the rest of them on your own and work on the homework. Starting off here, we start with a hint. When drawing Venn diagrams, we generally start with the intersection of the sets and work outward. So you want to find the pieces of information that are shared between 2 or 3 of the sets. If it's 3 sets, you want to find that 3 intersection first, and then work outward from there. So for each of these problems, we're going to draw a Venn diagram to answer the question, and we're going to show all of our work, which means that if I need to show some subtraction to figure out how many people would be left in a certain section, I would need to show that subtraction. So let's start. We have the Greens are moving to Athens, Georgia. Their real estate agent located 77 houses listed for sale in the Athens area in their price range. Of these houses listed for sale, 47 had a finished basement, 52 had a 3-car garage, and 35 had a finished basement and a 3-car garage. How many had a finished basement but not a 3-car garage? How many had a 3-car garage but not a finished basement, and either a finished basement or a 3-car garage? We're going to start by drawing our sets. In this case, we have 2. We have houses that have a finished basement. So we're going to call this finished basement. And on this side, we're going to call this 3-car garage. Okay. And they tell us that if I start with what's shared between both, what's the intersection of those 2 sets, 35 had a finished basement and a 3-car garage. So that goes in the middle. It has both. Okay, it satisfies both of those sets. So then they tell us that 52 had a 3-car garage. So that means that, I'm kind of working backwards, from here, in this entire circle, there is going to be 52. So 52, take away the 35 that has both, and we find out how many are left. So we're going to subtract, and that we end up with 17. Okay. Now we're told that 47 had a finished basement. So in the finished basement set, we know that that total needs to be 47. But we've already accounted for 35. So we subtract to figure out how many are remaining to fill this circle. So on the side, on the left-hand side, I did a little side work because I wanted to figure out how many had either a finished basement or a 3-car garage. So we count it if it's an either or. So what you do is you add up the 3 values from inside those 2 sets. So the total that has either a finished basement or a 3-car garage is 64. Whoever has a 3-car garage but not a finished basement, that's the 3-car garage minus the finished basement, that's 17. And how many had a finished basement but not a 3-car garage? That's going to be 12. Now look here. We added those up and we got 64. But there was a total of 77 houses. So that means that if I take 77 and I subtract 64, I'm left with 13 that do not fit any of these criteria. So 13 houses are within the houses that were listed, but did not have either a finished basement or a 3-car garage. So make sure you always account for that as well, because there could be a question that said how many had neither a finished basement or a 3-car garage? And the answer to that question would be 13. I'm going to skip number 2 because that's just another example of a 2-set Venn diagram. So I'm going to let you do that one on your own, or you can get additional practice from homework. But we're going to skip to number 3 as an example so that we can see an example that involves 3 situations or 3 Venn diagrams, 3 sets. So in a survey of 92 resorts, it was found that 27 had a spa, 55 had a fitness center, 38 had a children's club, 13 had a spa and a fitness center, 10 had a spa and a children's club, 19 had a fitness center and a children's club, and 7 had all 3 features. Now this is a lot of information for us to use to figure out how much goes in each section, each region of our Venn diagram. But we're going to have to answer these questions. How many have only a spa? Exactly one of these features, at least one of these features, exactly 2 of these features, or none of these features. So we're going to pause and take a slight detour, and then we're going to come back to this problem. The reason why I want to take a quick aside is because we're asked a few questions, and I want to make sure it's very clear what it's asking for. So when one of the statements says, which of these regions has exactly one of these features? So the phrase is exactly one of the features. That means that it's the areas where it's only one of the features. So there can be no overlap of the features. So those are these 3 regions. If an element of a set is in one of these regions that are shaded, they have exactly one of the features. Now, if it were to say, how many have exactly 2 of the features? That means those are our spaces that overlap between 2 circles, okay? But if it says exactly 2, it can only be the overlapping parts that overlaps only 2 circles, not the space that overlaps all 3. So A and B overlap here and here, but we can't count that bottom section because that also overlaps with C. So if an element or one of these resorts is in that middle section right there that I put a dot in, that means it has all 3 features. So therefore I can't say that it has exactly 2. So this areas where they are exactly 2 features are these 3 regions right here. Okay? Now, if it says which of these resorts or which of these regions has all 3 of the features, okay, so it would say all 3. That is the section in the middle. Only the elements or only the resorts in that middle section, section 5 if we labeled them with our Roman numerals, that's the only one that has all 3. Now let's pause and think, what if it said at least 2 of the features? So let's underline that, at least 2 of the features. So that means the words at least mean 2 or more, okay? So the sections that I already had for exactly 2 would be included. And the only section here that has the or more would be the one that has all 3 features. So if it says at least 2, we're talking about those 4 regions. So please be mindful of the phrasing. If it said at least 1, then that's the union of all 3 sets. If it says at least 2, it's the shaded region that we have here, okay? So please be mindful about which sections we're looking at when we answer those at least and exactly questions. So let's go back and look at the problem. We know that we're talking about resorts, so we're going to draw our Venn diagram, and we're going to label our sets S for spa, F for fitness center, and C for child care center, child club, okay? So we have our three sets, and our hint told us that we should start with the intersection of the sets. So we have 7 had all 3 features. Okay, so in that middle section, the one that's shared by all 3 of the sets, we place a 7. Working backwards, we're told that 19 had a fitness center and a children's club. So that's this area right here. Okay, it's the intersection of both of those. And we're told that there are 19 that should be in that section, but we've already counted for 7. So we're going to have to do 19 minus 7, and what remains is 12. So 12 goes in that section. We're then told that 10 had a spa and a children's club. So that's this section right here. That should have 10 elements of it. We've already accounted for 7. So we do 10 minus 7 to find out how many remain in that section. Then we're told I'm running out of colors. Let's see what I got. Green. We have that 13 had a spa and a fitness center. So spa and a fitness center, those 2 features, that should be 13 in that section total, but we already know we have 7 in that section. We subtract that and we get that this section should have 6. You know it's hard to see. Okay, I'm going to put black over that one just so you can see it better. Okay, so we've got our region where they share all 3. We've got our regions for the 2. Now we need to find out each individual circle. So let's start with this one. We know that 38 of the resorts had a children's club. So in the children's club circle, which I'm outlining in orange, okay, the total in that circle should be 38. But we've already accounted for 3, 7, and 12 of those resorts. So let's add up 3 plus 7 plus 12. 3 plus 7 is 10. 10 plus 12 is 22. So we're going to take 38 and subtract our 22 to figure out how many just have a children's club. So that gives me 16. Okay. Now we're going to let's do gray. We're told that 55 of these resorts had a fitness center. So in this one outlined in the darker gray, we know that that circle should contain a total of 55. But we've already accounted for 6, 7, and 12 within that circle. So we're going to add up 7 plus 12 is 19. 19 plus 6 is 25. And we're going to take 55, the total that needs to be in that section, and subtract our 25, which gives us 30. Okay, and then lastly, and I'm pretty much entirely out of colors, we have light gray. We're told that 27 of these have a spa. So in this, we have that entire circle that has a spa, and we've already accounted for 7, 3, and 6 within that circle. So 7 plus 3 is 10, 10 plus 6 is 16. So we're going to take 27, and we're going to take away 16, and what's left is 11. So now we can start answering these questions. How many of the resorts surveyed had only a spa? So we are going to look at the section that's the spa without any of the overlapping parts. So that we've already answered is 11. Okay. Now, B says how many of the resorts surveyed had exactly one of these features. So those are the sections where there are no overlap, but we're going to add them together. So that's this section, and this section. So that's 11 plus 30 plus 16. When we do that, we end up getting 757. Had exactly one feature. Okay. How many had at least one of these features? That's going to be anything contained in any of those inner circles. So we're going to add all of that up. The way I'm going to add these up is I'm going to take the 57 that I already know from these 3 sections and then add in the remaining sections. So when I do that, I'm going to end up with 57 plus 3, which is 60. 7 plus 6, which is 13, plus 12. That gives me 25. And so 60 plus 25 is 85. Now, of course, you could use your calculator to answer that and to add all of those up. But I can do it in my head, and hopefully you can too. So it helps with that. But you should always check with your calculator. It doesn't hurt. Now we're going to find the section, how many resorts had exactly 2 of these features. So remember, the exactly 2 are the ones that only have 2. So that's 6 plus 3 plus 12. So 6 plus 3 plus 12 gives us 18, 19, 20, 21, 21. And then based on our answer for part C, how many had at least one of these features? That tells us everything that's contained in those sets. So therefore, since we know how many have at least one of those features, and we know the total that started, if I take the total and subtract the 92 minus the 85 that have at least one of the features, then we end up finding out how many have none of the features. So that gives us 7. 7 resorts had none of the features. And that is how we fill out the information in these 3 set Venn diagrams. It's a big logic puzzle. So if you're a fan of logic and like working backwards and taking the information you already have and finding what's left, you'll have a blast doing these. If you don't like those, it might be a little bit more of a difficult thing to do, but hopefully with more practice and additional practice, you'll have no issues doing it in the future. All right. Thank you so much. Good luck with your homework. If you have any questions, be sure to email me. Thank you.